Okay, I just want to have a look at some more integration examples now in this screencast. I think actually through these examples here we've been talking about will have enabled you to get exercise 9A and exercise 9B questions done. Lots of practice in there for you, but I want to move on just to some different types of questions now where we can identify what this constant is, or we can calculate it, being given some more information. So I just want to really use this screencast to go over a few of those things. So firstly, example 1. Okay, so here's our question. If the derivative function f dash x equals 3x squared plus 2x and f2 equals minus 3, find f of x. Okay, so f of x is going to be found by integrating this f dash x here, 3x squared plus 2x. Okay, so I mean, more generally, if you want to look at it, then f of x will always equal to the integral of f dash x, and the derivative of f of x will be equal to f dash x. So that's the circuitous nature of that. So come back to when you're asked for f of x from f dash, or if you're asked for y from dy dx, then you're looking to integrate whatever that derivative function is. So here we are, this is our task. So f of x equals the derivative of this, sorry, the integral of this. So what do? We take the power and we increase by 1 and we divide by the new power. So if we do that to both these terms, 2x becomes 2x squared divided by 2. That 2 doesn't change. Just as in differentiation, the constant does not affect the integration process. So we just hold the 2, we increase the x by 1, by the power of x by 1, sorry, and then we divide by that new index value of 2. So right, so we need to plus c on the end of that, obviously. Let's just tidy this up. That's x cubed plus x squared plus c. Right, now this bit of information here is going to get c for us. F of 2 equals minus 3. Okay, so what I've got here is f of x. So f of 2 is going to equal 2 cubed plus 2 squared plus c, and I'm told that that equals minus 3. So now I can concentrate on solving this. 8 plus 4 plus c equals minus 3, and therefore c is equal to minus 15. So what we're asked to do is find f of x. So therefore f of x is equal to, go back up here, x cubed plus x squared. Now we know what c is. It's minus 15. So there's my function of x. Alright, stand by for example 2. Okay, you can see why I paused there. Kind of lengthy example 2. The curve y equals fx passes through 3230. The gradient of the curve is given by, here it is, f dash x is this. Find the equation of the curve. We've got the gradient function. This is working in the opposite direction to how we have been working. We've been given this, and then we've been finding the gradient function. Now we've got the gradient function. We're going back. That's called integration, isn't it? So we're going to go, what do we want? We want y equal, we want fx. We've got f dash x. So we're going to integrate f dash x, which is 1 over the 5th root of x cubed dx. Right, so we're going to integrate that. Let's put it in integratable form. X to the power of minus 3/5. And now we're ready to integrate. We add 1 to the power. Minus 3/5 plus 5/5 is 2/5. Divide by the new power, 2/5 plus c. Multiply top and bottom by 5. 5x to the 2/5 over 2 plus c. Right, this might be more easily workable if we just split this up to 5 over 2 by the 5th root of x squared plus c. Now we go and recruit the information we need to find c. 3230, the point 3230 lies on this point, sorry, on this curve, so 3230. Let's sub that value in for y, the function value equals 5 over 2 by the fifth root of x squared. Our x is 32 plus c. Alright, so now we need to solve this. 30 equals 5 over 2. Right, now how do we do this? This is the fifth root. I'm not going to square 32 first and then take the fifth root. I'm going to take the fifth root of 32, which is 2, and then square it to get 4. That's much easier. Therefore, 30 equals 5 over 2 times 4, which is 10, plus c. So c is equal to 20. So therefore, my function is equal to 5 over 2 by the fifth root of x squared plus 20. And we're through with that example. Okay, third and final example. Let's have a read through. The rate of growth of a population of fish is given by to P to T. P is population, rate of change of population with respect to time, 150 root T from 0 to 5 years. The initial population was 200 fish. Find the number of fish after 4 years. Okay, so we've got to P to T equals that. I want P, so P is going to equal the integral of 150 root T with respect to T. So that's my track back. Here's my derivative. Here's my integrate the derivative, get back to P. Right, so let's do that. Let's firstly get it in integratable form, 150 T to the power of a half to T. Right, when you've got big constants like this, let's get it into better integratable form. Take it out the front so we're not worried about it. You'll often find that you'll have a function to integrate, and it's going to be a lot easier to isolate that constant term. In this case, 150. Haven't thought about doing it before so much because they've been quite small values out the front. So here, this 3x squared, we could have removed the 3 and done that separately. So in this case, it's quite a let's get rid of the 150, put it out the front, isolate that, and so I'm just going to be concerned with integrating this here. So now I'm ready to go. It's just 150 by t to the, let's add 1 to the power, that's 3 over 2, and then divide by the new power, which is 3 over 2, plus c. Now, what do we do in this situation? We times by 2 here to get rid of the fraction. So we do the same to the top. So it's 150, all right, by, if you like, times 2t to the 3 on 2 over 3 plus c. And now we can just, what do you think? Can we do the 150 times 2, which is 300, over 3, which is 100. That's looking better, isn't it? T to the power of 3 over 2 plus c. Okay, so what do we know about this situation? Because I want to find out what c is. Oh, the initial population was 200 fish. Therefore, when t equals 0, population was, what did I say, 200? 200? Yeah. So, therefore, because this is population, therefore, 200 equals 100. When t is 0, 100 times, there's 0 to the 3 over 2. That's just 0. So therefore, usually the calculation of c is quite a trivial calculation. C is equal to 200. So now I've got my population equation at 100, t to the power of 3 over 2, which we might need to write as the square root of t cubed, plus 200. We found that out. Now what we need to do is find out what the number of fish at 4 years. So we're going to put 4 in here. At t equals 4, population is equal to 100 times, so this is 4 to the power of 3 on 2, 4 to the 3 on 2 plus 200. Okay, it's 100 times, what's this? This is the square root of 4, which is 2, cubed, which is 8. 100 times 8 plus 200, that's looking like 800 plus 200, or 1,000. Population at after 4 years, 1,000 fish. Okay, that's good enough. Let's go to exercise 9C. We're starting to get through this. Okay, see you soon.